This is Advanced Math 12.1 Notes. That's Unit 12, Lesson 1. And the title is Exponential Rules and Graphs. And we are going to simplify. Number 1, 36 to the 1/2, and I'm going to write number 2 as well, negative 25 to the 1/2. Okay, this is review. You've done these since Math 2, you did it again in Math 3. Remember, when you rewrite them, and that's what you do here, you rewrite them in radical form. This is exponential form. The denominator becomes the index, and the numerator becomes the power. So a 2 here and a 1 there. 36 goes on the inside, power of 1 and index of 2. Now here, only the 25 goes on the inside, the negative stays out. Because there's no parentheses here, that 1/2 is only being applied to the 25, not the negative sign. Okay, so here, this is pretty much just the same thing as just the square root of 36. You don't have to write all that stuff. That's just reminding you how it goes. And the square root of 36 is just 6. You are done. Okay, this is just the opposite of the square root of 25. The square root of 25 is 5. Opposite of that is negative 5. So negative 5 is your answer. Okay, now what if I do put parentheses in like this? If I do have parentheses, the 2 still goes here and the 1 there. I'm going to erase it and just write it as a square root with no numbers because it means the same thing. 1/2 power is the same as the square root, and negative 25 goes on the inside because it's in parentheses. And in this unit, we're only working with real numbers, not imaginary. So we would say here, no real solution. Number 4, negative 64 raised to the 2/3. Now be careful. Kids will look at this and right away say, oh, no real solution, because that's what happened here because it's in parentheses with the negative. But this negative 64, it's the cube root, because remember the bottom number, the denominator becomes the index. So it's the cube root of negative 64 squared. And you can take the cube root of a negative number. That is possible. So if this number is odd, you can work it out. If it's even, then you cannot. So if that was a 2, a 4, or a 6, and you have a negative number on the inside, no real solution. If it's a 3, a 5, or a 7 with the negative on the inside, you can work it out with a solution. Okay, the cube root of negative 64 is negative 4, because negative 4 times negative 4 times negative 4 is indeed negative 64. There still is a power of 2. Negative 4 squared is 16, because a negative 4 times a negative 4 in parentheses equals positive 16. Number 5, I'm going to redo that same problem, but this time with no parentheses, and see if that changes anything. So radical, the negative goes on the outside, 64, index is 3, exponent is 2, and the negative goes on the outside because it's not in parentheses like this one was. I take the cube root of 64, and then I square just the cube root of 64, not the negative. Pretty much that you're just going to take the opposite of whatever all of that becomes. So I'm going to leave my opposite sign there. The cube root of 64 is 4 squared. And again, it's the squared is only applied to the 4, not that negative. You're pretty much just going to take the opposite of whatever your answer is. 4 squared is 16, and the opposite of that would be negative 16. So it did change the answer. Okay, number 6, 2 to the 4th times 3 to the 12th raised to the 1/4. Now, if you wanted to, you could do 2 to the 4th power, 2 times 2 times 2 times 2. Not that bad. 3 to the 12th power is going to be really big, and then multiply it, and then it's going to get really complicated. So, because this is multiplication, you are allowed to distribute that exponent. That's only because it's multiplication. If it was addition, you would have to find another way to do it. Okay, so let's distribute the exponent. Power to a power, reminder that you multiply. Power to a power, 4 times 1/4 is 1, so it's 2 to the 1, times 3, 12 times 1/4 is 3. So I have 2 to the 1 times 3 to the third, which is 2 times 27, which equals 54. So just a reminder that when you have a power to a power, you multiply. So if I have x squared raised to the 4th power, that would equal x to the 8th power. A power raised to a power, you multiply. Okay, number 7, 0.01 raised to the 3/2. How in the heck do I work this out? Change the decimal to a fraction. The way you read this is tenths hundredths, so this is 1/100th because it's in the hundredths place. So 1 over 100. If you plug 1 divided by 100 in your calculator, it would give you 0.01. So we're going to raise this to the 3/2, which means we're going to take the square root of 1 over 100 and raise it to the 3rd power. Index of 2, power of 3. What is the square root of 1 over 100? That's 1 over 10, right? Because 1/10 times 1/10 is 1 over 100. And we raise it to the 3rd power, and I end up with 1 over 1,000. Number 8, 0.001 raised to the negative 2/3. Okay, so I'm going to do 2 things at a time. I'm going to change it to radical form and change that decimal to a fraction. Tenths place, tenths, hundredths, thousandths, so it's 1 over 1,000. Index is 3, power is negative 2. Whenever there's a negative, you always leave it on the numerator. So say it was written like this, which does happen sometimes, like the negative is right in the middle of the fraction. Kids always like, oh no, where do I put the negative? Well, you don't put it on both, you put it on one, and you just always put it at the top. The index here should not be negative. So leave the denominator positive, the exponent negative. Okay. Cube root of 1 over 1,000 is 1/10. So I have 1/10 raised to the negative 2nd power. And remember, a negative exponent flips your base, so you're going to, it reciprocals your base. So 1/10 is going to become 10, and the negative becomes positive. Okay, so the negative exponent flips your base, reciprocals your base, 1/10 becomes 10, and negative becomes positive. That is 100. Another way to think about it, if that is a little confusing, is distribute your exponent, and you can do that because it's a division. So you do 1 to the negative 2 over 10 to the negative 2. If you don't need this explanation, you can fast forward. Negative exponents, they move places. So the 1 to the negative 2 is moving to the bottom, 1 to the positive 2. 10 to the negative 2 is moving up, 10 to the positive 2. 10 to the positive 2 is 100. 1 to the positive 2 is 1. 1 over 100 is just 100. It's up to you and how you want to do it, what works best for you. Okay, moving on. There's a lot of notes to get through for this lesson, so I'm going to try to speed up. Number 9, 6 to the 4/3 times 6 to the 2/3. Okay, to do this one, I'm just going to put another little thinking bubble here. A reminder, this is properties you learned back in middle school, that when you have something like this, x squared times x to the 4th, you don't multiply it like we did earlier, you add them. So you would get x to the 6th, because 2 plus 4 is 6. Okay, now remember as well, the base stays the same. Look at that, x times x, and it stayed x. The only thing you did was add the exponent. So as tempting as it is to say 6 times 6 is 36, you do not. It's going to stay 6, and then you add the exponents. 4/3 plus 2/3 is 6/3. 6/3 reduced to 2, and 6 squared is 36. Okay, number 10. 7 over, and I'm going to change this, not change, but on this top 7, I'm going to add an exponent of 7/3, and the denominator is 1/3. Okay, now here we added, here we subtract. So I'll just add it here. If I have x to the 6th over x squared, kids think, oh, divide because it's a fraction, and 6 divided by 2 is 3. No, you subtract. 6 take away 2 is 4. So when it's multiplying like bases, you add. When you're dividing like bases, you subtract. And lucky for us, they already have a common denominator. So it's going to become 7 raised to the 6/3 when you subtract, which is 7 squared, which is 49. Final answer. Okay, number 11. X raised to the square root of 2 divided by x raised to the square root of 18. Okay, now a few things that's going to happen here. First off, they're like bases, so I can either add or subtract. Since it's a division, I'm going to subtract because it looks like that one right there. If it helps, you can rewrite it as a division. Okay, root 2, root 18. Now what am I going to do with the root 2 and the root 18? I'm going to subtract. Now right now I cannot subtract them because they're not like terms. So what I'm going to do is I'm going to simplify radical 18. So I'll do that over here. Radical 18 is what? 2 times 9? And you can take the square root of 9. Square root of 9 is 3, so it's 3 root 2. Okay, so I'm going to rewrite it as x to the root 2 over x to the 3 root 2. Do you see how that works? And then I'm going to do 1 root 2, take away 3 root 2. 1 root 2, take away 3 root 2, which is negative 2 root 2. I'm not done, but do you see how that works? There is a 1 there. 1 root 2, take away a 3 root 2 is negative 2 root 2. And it will ask you to write everything with positive exponents. So this becomes 1 over x raised to the 2 root 2. Looks a little wonky and complicated, but we can handle it. Okay, number 12, 8 to the 12th over 2 squared. Now you can only subtract the exponents if the bases are the same. Unfortunately, the bases are not the same, so there is some simplifying we have to do. Is there any way to get them to the same base? Well, 2 squared is 4. That's still not going to be the same base. I'm going to change the 8. I can't change the 2 because I'd have to put more numbers in there. 2 to the 3rd is 8, and I can't just throw a 3rd in there. But 8 is the same as 2/3. Okay, so what am I doing here? All I'm doing is changing this 8, and I'm changing the 8 to 2 to the 3rd power. So I'm not changing the value at all. I'm just changing the way it looks. We know 2 to the 3rd is 8, so these two are still equivalent. So I multiply power to a power. We talked about that previously. That's review. 3 times 12 is 36 over 2 to the 2nd, and now they're like bases. We're ready to subtract. 2 to the 34th power. Okay, number 13. I am going to put up here true false. We're going to go over some true false questions. Okay, 2 to the 2x equals 4 to the x, true or false? Okay. Pick a side, it doesn't matter which side, and manipulate it, kind of like we did with those proofs a few units back. See if you can make them equal. And you can change both sides, it does not matter. Okay, I'm going to change this side, kind of like I did over here with the 8 when I rewrote it. 2 to the 2nd is the same as 4. Do you guys agree that 2 squared is 4? So I'm not changing its value, just the way it looks. And we know a power to a power, we multiply. 2 times x is 2x, and it sure enough equals, so this is true. Okay, number 14. 2 to the x plus 2 to the negative x equals 2 plus 2 to the negative 1 raised to the x power. Okay, so what they're trying to get you to see here, is it okay to take this exponent and distribute? If I were to distribute, I would get 2 to the x, because there's a 1 there. 1 times x is x. Negative 1 times x is negative x. So is it mathematically correct to distribute your exponents? The answer to that is no. This is a false. Why can you not distribute the exponent there when on the previous problem over here I said distribute? The reason you can distribute here is because it's multiplication. So you can distribute an exponent when it's multiplication or even when it is division. But if it is addition or subtraction, like it is here, you are not allowed to distribute the exponent. Addition or subtraction inside your parentheses, you're not allowed to distribute the exponent. So it is false. Okay, number 15. 2 raised to the 3 plus 3x equals 8 raised to the 1 plus x. Okay. Don't just look and say, oh, false, like the last one, there's no way. You do have to think about it and do some work and see if you can get it to work. Okay, I'm going to try to get these two to be the same base. Like this one over here, number 12, I'm going to pick the larger number, the 8, and change it. Because 8 is equivalent to 2 to the third, I'm going to leave the 1 plus x there. So again, I'm changing the way it looks, not what its value is. 2 to the third is still 8. Now, a power to a power, I multiply. So I'm going to have 2 raised to them. I'm going to multiply 3 times 1 plus x. Now, why do I do that? Because a power to a power, we multiplied. I talked about that on the previous page. And then you just distribute the exponent, 3 plus 3x. And this is regular distribution, not like over here where you're distributing an exponent. This is just 3 is the coefficient to 1 plus x, so you distribute. There it is. There it is. That is true. Okay, 16. 5 to the x times 4 to the x equals 20 to the x. Now this one is a little tricky, so you want to make sure you're paying attention and really thinking about it. Okay, for me personally, I look at this and the first thing I see is no way. This is false, because when have we ever multiplied bases? We add exponents, but we don't multiply bases. We just don't. So my first thought is false. Now also, they have to be like bases in order to add the exponents, which they're not. Okay, now, like I said, you do have to think about it. What if I change this side 20 to 5 times 4? Is 5 times 4 still 20? And is 20 still being raised to the x power? Yes. Okay, so far so good. Now, I just said previously, you cannot distribute an exponent when it's an addition, but you can when it's multiplication. So we are allowed to put that in there. And you multiply the exponents, they both have a power of 1. So 5 to the x times 4 to the x, which is indeed what we started with, so this is true. So what I'm getting at is be careful. All right, just a few more. 2 to the x plus 2 to the x equals 2 to the x plus 1. Another one that comes up, and this will come up on your take-home quiz. This is another one that kids look at and like, oh no, it's not going to work. Be careful. Okay, now here's what I would suggest. Use substitution. That's the best way I can explain it is to use substitution. So we're going to let u equal 2 to the x. Okay, so I end up with u plus u. U plus u is 2u. And now I'm going to plug the 2 to the x back in for the u, so I end up with 2 times 2 to the x. Okay, what have I done? I took this, put them both, u for both of them, so it's u plus u. U plus u is 2u, and then I put the 2 to the x back into the u. So it's 2 times 2 to the x. Because they are like bases, I can add the exponents. There's a 1 there. 1 plus x, the base stays 2. 2 raised to the 1 plus x is the same as x plus 1. That there is true. Confusing, I know. So we'll try another one. This one, I'm not going to have it as true false. I'm going to put simplify, because you will have some where you have to simplify as well. 3 times 2 to the 2x plus 2 raised to the 2x. So I'm hoping you can see that here, this right here is what I'm going to let my u equal. All right, so that gives me 3u. The 3 is going to stay there. 3 times 2 to the 2x, so 3 times u. I don't have to put a little dot there. You can. Plus u. That's what I'm going to have to simplify. 3u plus u gives me 4u. All right, and then I'm going to plug the u back in. So 4 times 2 raised to the 2x. Now I want to simplify this, so I need to change the 4 to a base of 2, kind of like I did on the previous page. So 4 is 2 squared times 2 to the 2x. Do you see how that worked? 3 plus u is 4u. 4 I'm going to change to 2 squared, because 2 squared is exactly the same thing as 4, and then add the exponents. So it becomes 2 plus 2x, they're not like terms. 2 plus 2x is how it's going to stay. That there is your answer. Okay, the last thing I'm going to go over is the graphs. Now, I typically would make a T-chart, but I know I've been running notes for a while, so I am going to just do a quick reminder of how to just sketch it. Okay, so all you really need to know for quizzes and tests and math classes next year is which one's growth and which one's decay, and what do exponential growth and decay look like. These are exponential functions. Now, if you remember from last year is when you did a lot of these. As long as there was no translation, the intercept here was 0, 1, and it approached 0 as an asymptote, and it grew up like that. Okay, so there is the exponential growth. Now, exponential growth will happen whenever that base there is a number bigger than 1. It's never going to be 1, but it has to be a number bigger than 1. 2, 3, 4, 4.5, 5, or even 5 over 2. As long as the base is bigger than 1, it's going to be an exponential growth. Okay. Now, and the exponent's positive. Of course, it has to be positive. So what do I do with this one if it's not positive? Remember, a negative exponent changes your base, so 2 becomes 1/2, and the negative exponent becomes positive. Now that my base is smaller than 1, it's going to be an exponential decay. Now, if you remember that the x-axis here is an asymptote. It gets really, really close but never touches. Exponential decay just goes the other way. Still goes through 0, 1. And this is an exponential decay. And that happens when the base is less than 1. You always want your exponent to be positive. So if it's not positive, flip your base, reciprocal your base. In this case, 2 became 1/2. And then the negative exponent becomes positive. 2 is bigger than 1, it's a growth. 1/2 is smaller than 1, it's a decay. All right, and that is it for this lesson.